This lesson is called circle terminology. We're going to learn about the parts of the circle, how to name them, how to identify them. We'll learn about inscribed and circumscribed polygons, and then we'll learn about different types of arcs, and finally talk about the radius and the diameter and circumference of a circle. So the definition of a circle is the set of points that are coplanar and equidistant from a given point. The given point is called the center, and that distance is called the radius. And when you're referring to the radius, you'll give it a lowercase r. Here's some different parts of a circle, types of segments and other things. A chord is a segment whose endpoints lie on the circle, like this segment. It starts and ends on the circle. A diameter is a type of chord that goes through the center. It's the biggest chord there is. It goes across the largest part of the circle. It's the diameter. Since it goes through the center, the diameter is also twice as long as the radius. We'll get to that again later on. A tangent, that's a line that intersects the circle at exactly one point, just like a tire on the road. The tire on your car touches the road at one point, and that is a tangent. The road would be the tangent, and the tire would be the circle. The point where the tangent touches the circle is called the point of tangency. Right there's the point of tangency. And finally, a secant, that's a line that contains a chord. Another way you could put that is it's a line that touches the circle twice. A tangent touches the circle once, and a line, or a secant, is the line that touches the circle twice. So in this figure, let's identify the chords, the radii, and the diameters. Notice radii is the plural of radius. So what are the chords? Any segment that has endpoints on the circle, like segment AB, segment BF, and segment CE. The radii go from the center to the edge of the circle. All of these have point O listed because point O is the center. Notice they also have segment OA, even though it wasn't originally drawn, segment OC, and segment OE. It's still a radius even if it's not drawn, so those could also be included. A diameter, that would be segment FB. It's a chord that goes through the center. Here's some more definitions. Congruent circles, well, they have to be the same shape and the same size. And since all circles are the same shape, they have to be the same size, so they have to have congruent radii. Concentric circles are circles that are in the same plane and they have the same center, and they sort of look like a bullseye. Concentric circles, same center. Congruent circles, the same radius measure. Inscribed polygons and circumscribed polygons we have here. An inscribed polygon is a polygon inside the circle whose vertices lie on the circle. So we have here a pentagon that is inscribed in the circle. Every vertex of the pentagon touches the circle. Inscribed sounds like inside. That's one way to remember it. The inscribed polygon is inside the circle. A circumscribed polygon is a polygon whose sides are tangent to a circle. The circumscribed polygon is outside of the circle, and each side is tangent to the circle. And you can see the 3 points of tangency as you go around here. Inscribed polygon is inside. Circumscribed polygon is outside. Then we have arcs. An arc is just a portion of the circle. It's not the whole way around, it's just a part of it. The arc from B to C, you would call it arc BC. And instead of a segment bar or a double arrowhead, you would have an arc over top of it just like that. Each endpoint is in the arc. You could call that same arc CB. You might also have a semicircle that goes halfway around the circle from A to B to C. And when it goes at least halfway across, you have to name it with 3 letters. It'll start with one endpoint, then it'll have one point in the middle, and then it'll finish with the other endpoint. And put a big arc over top of all 3. If it goes less than halfway across, then you only use the first and last point. But if it goes halfway around or more, then you have to use 3 points. If it goes less than 180 degrees, then it's a minor arc. The short distance from A to B is a minor arc. You would call that arc AB. A major arc, if it went more than 180 degrees, like from A through B and around to C, that's arc ABC. You could also call that arc CBA. But you have to have that point in the middle that's somewhere along the path from A to C. So if it's under 180 degrees, you can just use the 2 endpoints. If it's halfway or more, you have to use 3 points. Use the 2 ends and any point in the middle. Identify a minor arc, a major arc, and a semicircle, given that segment CD is a diameter. Well, a minor arc is any arc that's under 180 degrees, like the arc from C to E, make that a little bit more round. There we go. The arc from E to D, the arc from D to F, and the arc from F to C. All of those are minor arcs. Major arcs go more than halfway around the circle, more than 180 degrees worth. A major arc, like from C to E to F, you could call that arc CEF or arc CDF. D is also along the way. We also have the one that goes the long way from E to C. This one would be EDC or EFC. You also have the long way from D to E, that would be DFE or DCE. And the last one goes from F around to D, and that's FCD or FED. Semicircles go halfway around. We have two of those. One from C to D that goes through E, so that'll be semicircle CED, and the other one goes along the bottom route, CFD. You wouldn't call a semicircle arc CD, because from C to D, how do I know if I'm going the top way or the bottom way? You don't. That's why you have to give it that third point. So minor arcs can be named with 2 points, but major arcs and semicircles have to have the 3 points. And when you're comparing a radius and a diameter, the radius is equal to half the diameter. So you could write those, let me write those a little bit neater. R equals D over 2, or R equals 1/2 D. Either way, the radius is half the diameter. Another way to look at that is that the diameter is 2 times the radius. D equals 2R is another formula you can use between the diameter and the radius. The circumference, which is the distance around the circle, C equals pi times D, pi times the diameter, or C equals 2 times pi times the radius. Notice the circumference is capital C. The diameter is lowercase d and the radius is lowercase r. And pi is approximately 3.14. Most of the time we'll just use the pi button on the calculator. So let's do some more examples here. Let's name this circle. Well, this circle has center L, so we'll call it circle. There's the center, or the symbol for a circle. Draw a circle with a center point in it, followed by the center point. Circle L. Name a radius of the circle. Well, there's 3 to choose from. All of them have point L. Segment LR, segment LT, or segment LW. Name a chord. We have 3 chords also. Chords have endpoints on the circle. Segment RS, segment ST, and segment RT. Each of those segments has endpoints on the circle. And then name a diameter. The diameter is the chord that goes through the center, and that's segment RT. The radius, diameter, or circumference of a circle is given. Find the missing measures to the nearest hundredth. If you're given the radius of the circle, well, let's find the diameter. Use the diameter formula. D equals 2R. And substitute in the radius. D equals 2 times 7.5. And then work that out. 2 times 7.5 is 15. So that's 15 centimeters. For the circumference, you have 2 choices. You could do C equals pi times D, or C equals 2 pi r. If you do pi times d, you get pi times 15. If you punch in the pi button times 15, you get approximately 47.12. If we instead did 2 pi r, c equals 2 times pi times 7.5, we get the same exact thing, 47.12. So it's really up to you if you want to use pi times d or 2 pi r. Now sometimes your answer will be given in terms of pi. So since you have 15 times pi here, they might have your answer just be 15 pi. And that's what you would give. But since this says round to the nearest hundredth, then we go ahead and work that out. Do the math on the calculator, and we get about 47.12. If we're given the circumference, it's easiest to find the diameter first. So let's use c equals pi times diameter. C is 227.6 equals pi times diameter. Since it's the diameter times pi, we'll do the opposite operation and divide both sides by pi. The pi's cancel over here, and 227.6 divided by pi is approximately 72.45. So that's 72.45, and the label is yards. If you're looking for the radius is the diameter divided by 2. Substitute in 72.45 for d and divide by 2, and that's about 36.22. So use the formulas to substitute in the piece you know and solve for the piece you don't know. And that'll do it.